This is Objective 4, Practice Test B. We're going to focus in on the second question. Again, the objective deals with theoretical yield, actual yield, and the measure of the efficiency of the reaction called percent yield. To begin our second problem, I'll read through the reaction. Aqueous tin 4 nitrate reacting with aqueous sodium hydroxide. We'll turn those words into a balanced equation for the letter A. Tin, whose symbol is Sn, the Roman numeral tells me it will be carrying a +4. And the nitrates, the polyatomic ion NO3, carries a -1. Tin 4 nitrate is SnNO3 taken 4 times. It will react with aqueous sodium hydroxide, Na with its +1, OH with its -1, NaOH, sodium hydroxide. The pattern of chemical change we are looking at is a double replacement. For tin, we'll go to the hydroxide, sodium to the nitrate, two positive ions exchanging partners. The first product I'll write would be tin, carrying its +4, now hooking to hydroxide with a -1, SnOH taken 4 times. And sodium goes to nitrate, sodium +1, nitrate -1. So NaNO3. We'll next work to balance our equation. Balancing first, the tins are good. How about the nitrates? We'll balance by placing a 4 in front of the sodium nitrate and then backing up to repair the sodium hydroxide with a coefficient of 4. So a 1-4-1-4 stoichiometric ratio. If this reaction proceeds with a 96.3% yield, how many grams of the precipitate are formed? We're beginning with 46 moles of tin 4 nitrate and reacting with excess amounts of sodium hydroxide. In this reaction, the efficiency is provided as 96.3%. We will work a stoichiometry problem that will target the theoretical yield. And the precipitate, out of our two choices, we need to determine the target product. Tin 4 hydroxide is our precipitate, knowing that sodium nitrate would remain soluble. And the tool that we use there is the solubility table. Sodium nitrate is soluble, tin 4 hydroxide is a precipitate. If we start our problem with 46 moles of tin 4 nitrate, that places us already in the center of our stoichiometry map. If we're given a mole and asked to calculate mass, we need 2 parentheses. We're already in the heart of our problem where we want over given ratio, and we'll use the molar mass of our precipitate, the product tin 4 hydroxide. I'll get my 2 parentheses ready so I can see the target. Where we want to land is grams of tin 4 hydroxide. Given a mole, we're ready for the heart of our problem, the want over given stoichiometric ratio. We want the tin 4 hydroxide, its coefficient is a 1. SnOH taken 4 times is the precipitate. Starting with the tin 4 nitrate, its coefficient is also a 1. So our stoichiometric ratio is a 1-to-1 ratio. We will need the molar mass of our precipitate tin 4 hydroxide. Let me calculate that. Tin, who has an atomic weight 118.7. There are 4 oxygens at 16 apiece, 16 times 4, plus 4 more on the hydrogen. 186.7 grams is the molar mass in every 1 mole of tin 4 hydroxide. I will hit 46 times 1/1 times 186.7 gives me an answer of 8,588.2 grams of tin 4 hydroxide.
Caitlin Sander, please come to the reception office. Caitlin Sander, please report to the reception office.
This is known as our theoretical yield. If our reaction had 100% efficiency, we would expect 8,588 grams of product. But our reaction was only 96.3% efficient. So I'm going to take 96.3% of my theoretical yield, and what we will find is called our actual yield. Taking 8588.2 that's still on my calculator screen, and I'm going to go times 0.963, turning my percent sign back into a decimal form. And my actual yield reports 8,270.4
Mr.
grams
Mitchelson, please call
tin
3770.
hydroxide.
Mr. Mitchelson, please call 3770.
In the next problem, we want to know how many formula units of sodium hydroxide are consumed during the course of this reaction. During this reaction, we have two reactants. Just to refer back to our equation, sodium hydroxide is being used right along with the tin 4 nitrate. We want to count the number of formula units. That tells me on the stoichiometry map, given a mole, we want to know the number of particles of the other reactant. This again will be a two-step journey. We'll divide want over given, and then we'll multiply to head out, starting with the 46 moles of the first reactant, tin 4 nitrate. We will go through the heart of the problem and end up with formula units of NaOH, our second reactant. Our stoichiometric ratio, for every 4 moles of sodium hydroxide, NaOH, I need 1 mole of SnNO3 taken 4 times, tin 4 nitrate. The want over given is 4 over 1. To count the formula units, we will take Avogadro's number, 6.02 times 10 to the 23rd. Formula units is the vocabulary word associated with the type of particle made of ions. Sodium hydroxide are 2 ions hooked together, creating the formula unit. So what we're counting, formula units, NaOH, and every 1 mole of NaOH. 46 times 4 times Avogadro's number, I report 1.1 times 10 to the 26th formula units of NaOH would be consumed given the number of moles of tin 4 hydroxide.